Please join me in welcoming our Senior Vice President of Software, Manish Kothari.
Good morning, everyone. Hi. My name is Manish Kothari, and I'm the Senior Vice President of Software Development here at Silicon Labs. I work out of our Hyderabad office, where I lead an incredible team that's focused on the software side of our industry-leading IoT platform. Software plays a central role in IoT. It's not only how developers build their products, but it's also how devices operate in the field and reliably for 10 or more years. From the models and algorithms that deliver functionality to the tuning that is required for low power and high performance, software is what ensures that these devices work in a wide variety of real use cases that our customers depend on. Silicon Labs has a rich history of software innovation and leadership. We have built standards-based stacks that power much of the connected world, including Bluetooth, Wi-Fi, sub-gig, Sidewalk, Matter, and Thread, and Z-Wave. As Amazon's leading wireless partner for sub-gig, we have helped advance their Sidewalk ecosystem. We've also played a critical role in shaping Thread and Matter through the Connectivity Standards Alliance, and we are the #1 semiconductor software code provider to the Matter community. We have contributed to and helped define the standards, but we also continue to lead in how these standards are implemented and optimized for the edge. That combination of standards leadership, long-term reliability, and software expertise is what makes Silicon Labs unique in IoT. At Silicon Labs, we believe it's the unification of powerful hardware like our Series 3 devices that Bob just talked about with co-optimized software that will unlock use cases for IoT. Here are a few examples that we're really excited about. Let's start with asset tracking. With software-driven intelligence on our wireless SoCs, devices can now locate and monitor assets with greater precision and lower power than ever before. This opens doors in retail, healthcare, logistics, where tracking location and condition of assets is mission critical. Let's talk about RF sensing. As Matt showed us earlier, using AI ML, we're pioneering ways to use radio waves themselves as sensors. Software models and algorithms make sense of reflected signals to measure motion, location, presence, and even vital signs, all without any specialized hardware. On the connectivity side, we're using advanced techniques like channel sounding to deliver precise location and ranging. Think of it as a way of giving the IoT devices the ability to see their surroundings with radio waves. And that can enable everything from secure access control to context-aware automation. How Silicon Labs is shaping the future of IoT with a step function transformation that will empower developers to build smarter, faster, and more efficient solutions at the edge. And today, I'm excited to share a bold step forward for all our developers who build on our platform. Our AI-enabled software development kit is here, and we're calling it the Simplicity AI. For years, we have optimized our tools, documentation, and workflows for humans, as you can see on the screen here. But now, something new has entered the scene. AI itself is becoming a developer. Agents and co-pilots are starting to code, debug, and integrate alongside humans. Our job now is to build a platform that works just as well with these agents as it does with you. That's what Simplicity AI is all about. A developer experience designed not only for the people, but for the AI agents that are working with them. Dynamic context engineering is really at the core. It means an AI agent has the right context at the right time so it can accelerate the entire development journey, starting from ideation to project creation to debugging and even deployment. This has required us to re-engineer every layer of our ecosystem, the SDK itself, the talks, the tools, so that they are structured, machine-readable, and agent-ready. The outcomes are powerful. faster development cycles, debugging that adopts and corrects errors automatically, the ability to combine and extend sample applications into new ones, and perhaps the most exciting is the potential for the developers and their AI teammates to build applications that we could never imagine before. We all know that software development is one of the biggest pain points for you, our customers, face. It's time-intensive, requires deep expertise, and slows the path from idea to product. Today, for the first time, we're going to show you a new way of working with our SDK, built not just for the developers only, but also for the AI agents that are becoming part of your workflow. Simplicity AI is on the horizon, and we are building a roadmap with your input. It's more than just an experiment. It's a long-term direction that will expand across all our wireless technologies. Now, let me show you what this looks like in action. I'd like to invite Michael Webb, one of our software engineers in our R&D org, to demonstrate this. Hey, Michael.
Thanks, Manish. Hello, everyone. In embedded development, it's critical to give the AI agent both detailed knowledge of the SDK and access to real hardware and local tools. That's what allows the agent to enter the powerful agentic loop, which drives AI-assisted development. So now, let me show you a live demo. I'm opening Cursor. I have Cursor open here with our Simplicity AI MCP tools installed. I want to build a Bluetooth thermometer application using the internal sensors starting from this empty Bluetooth project. How do I do this? So I sent the prompt to the agent. The first thing it asks, I need to get more documentation for that. So I want to call search docs, which is an MCP server. Calling it. Great. So it gives us a summary of the specific information for this use case. It gives us setup steps for what to do to create this project. It calls out key APIs and callbacks, key files to edit, planned project changes, and an entire build workflow. Now I want to elaborate. I want to go a little bit deeper and know exactly what components I need to update in my project. So let me do a follow-up question. Specifically, what Silicon Labs components should I add? It's going to call search components, which hits an MCP server to get the relevant components for this application. It calls out health thermometer is a component. It calls out a lot of these extra dependencies that are required for health thermometer. It tells you even how to add them to your SLCP file. It calls out the key callbacks required for taking these temperature measurements and key files to edit. So we now have the groundwork in place to start developing this application. In real time, this process would take the agent about 20 minutes. So instead of making you wait, I'm going to hand it back over to a video that we created to show the full flow.
Let's create a Bluetooth project with two boards. One board measures the temperature and sends it to the other. That board then indicates the temperature by changing the color of the built-in RGB LED. First, the AI searches through our library of sample projects to find a good starting point. The AI then discovers the two boards that I have physically connected to my machine and adapts the two sample applications to those two boards. I now specify exactly how I want the light to change, depending on the temperature that is measured on the other board. Great! The AI has found an existing driver to control the LED, and instead of writing something from scratch, simply reuses that code. Now, the AI has developed the code to actually control the color of the LED. Now we ask it to build the project, solving any compilation errors that might occur. Now we ask it to flash the examples onto the connected boards. Let's see what happens. How disappointing. It's not working. Luckily, this allows us to demonstrate automated debugging of embedded hardware. Let's tell the AI what went wrong. Great. The AI has found the issue and fixed it, and is rebuilding the image. And now it flashes that image so we can try again. To verify that things work correctly, it now connects through a UART to the device to see the debug log messages. According to the logs, the functionality should now be present. Let's see if it's right. Let's try it out. I touch my finger on one of the devices to increase the temperature, and I see the colors changing. And when I remove my finger, the temperature goes down and the color changes again. Success. But what if there's an underlying issue with the network? Let's ask the AI to capture some network traffic for us. The AI figures out what boards are connected and asks for permission before capturing the network traffic. We'll let it run for a while. Now we've got a trace of the network traffic. Let's use network intelligence to analyze the trace and see if anything is amiss. The AI asks us for permission to run the tool, and we say yes. The tool has run the complete analysis of the trace and has given us a clean bill of health.
Folks, this is super exciting. I think imagine this, imagine you have a mesh network. Imagine, this is just a two Bluetooth boards, point-to-point BLE, but imagine a mesh network of BLE nodes for your commercial lighting application, or in your home, a Zigbee network for your home automation, hundreds of nodes that you want to debug. This is what an agentic debug looks like. What you saw was a real developer journey. A project created, built, flashed, debugged, and fixed. Alongside with, fixed with an AI agent, with Michael in the loop, on our SDK. This is not about just saving some keystrokes. It's about a new way of developing where tools become collaborators, where an agent can extend a sample app, stitch together two reference apps, or even create something entirely new from our docs and software and API. And this is just the beginning of AI-enabled, AI-native SDK designed from the ground up for you and the agents that work for you. Dynamic context engineering will keep surfacing the right code, the right docs, and the right tools at the right time, so you spend less time searching and more time building. For developers, it means faster iteration, quicker debugging, and the freedom to imagine applications that weren't possible before. For the community, it means lower barriers and broader adoption. Silicon Labs is proud to be the first to deliver this experience for wireless IoT. And this is just the start. The roadmap is rich, and we'll keep building it together with you. If you want to be amongst the first to try, please sign up with our waitlist with your Silicon Labs sales team. This is your opportunity to help shape the journey with us. This is the vision, and Silicon Labs is at the forefront. Stay tuned to hear much more on the rollout of our AI developer tools next year.